Ladies and gentlemen, this is Joe's Classic Video Games, back with another cool pinball repair video for you this evening. We have been working on this Williams Flash pinball machine. There is the back glass right there. And it's just like this Williams Flash pinball machine. This Williams Flash pinball machine has been courteous enough to support the lockdown bar that came off of its brother here. They might have been built right next to each other on the line. What do you think? I wonder if there is a serial number I can see easily on these. Can't remember where they put them. Is it right here? I think it's on a bally. I feel something there. Let's see. Nope. Boy, it'd be cool to find the two serial numbers, wouldn't it? Just to see how close they were to each other. I'll look into it. I'll find it, people. Don't worry about it. But we fixed this one on a previous video, and then we did a video on this one. It came to us with a lot of little minor issues. It was crashing, and we figured out that the connector on the on the MPU is popping off on its own. Very strange. And then we rebuilt the power supply a little bit, and then we played through it a little bit, and it blew the solenoid fuse. And it has something to do with the drop targets resetting or something. I got it on tape, actually on film. Wait, I'm not taping or filming. I got it on digital. You know what, people? I'm going to say tape. I got it on tape blowing the fuse. So these reset and locked up, and it blew the fuse. So, but we didn't even hit those. It was like some switches up here that were doing it. So I don't know. We might have a switch problem or something. So we got to figure that out. But the main thing I want to do in this video is set the game up a little better. I'll show you what I mean by that. You can have a game that's working, but if just a few little things are wrong with it, it's nowhere near as fun as it ought to be, right? So one of the things that will make a game not very fun is if it's too flat, if it doesn't have enough of an angle on it. So on this particular one, the front legs are pretty much all the way in, the leg levelers, and then the back ones are about halfway out. And so that's giving it a little bit of slant. People ask, you know, what degree is it supposed to be set at? I don't know, folks. I'm not going to get out a meter and measure it. You can do that if you want, but they're all different depending on when they were built anyway. So some are more steep than others. So you kind of just do it the way you like it. I like it about how steep this one is for this era of game. I just kind of eyeball it. But you want to have a little bit of an angle on it, or the ball doesn't roll fast enough to be fun, basically. It makes them real floaty. The ball will roll left to right a lot more when it should be rolling up and down mostly, right? So there's that, and then there's little gameplay things. So I'm going to set up the tripod and just show you kind of how this one's playing right now, and then we'll go through and try to fix a little bit of the stuff and get it to play a little better, hopefully. So let me set up the tripod. We'll play a couple games. We're also looking to see if at some point, if we hit around this area, and I've done it with my hand and all that, I can't get it to do it, but if the ball's bouncing around this area, if it makes the fuse blow again like it did earlier. I have a circuit breaker in there now, but it should pop that circuit breaker if we have the same issue that we had before. So let me set up the tripod. Let's play it a little bit. All right, we'll play it a little bit. So the first thing I'll show you is that whenever you shoot the ball on this particular game, it should go across and up one of these, this kind of figure eight thing over here, but it doesn't. Right? So that makes it very much not fun. Right? Now what it just did, that gate, is it supposed to be able to go both ways through that gate? I don't believe it is. Maybe. No, it is not. So that too. So whenever the ball makes its way up there, it should go through this gate, and then the whole purpose of it is to keep the ball from going back, so that it has to go down one of these 4 lanes or back around through the spinner shop. So I'm going to make a list. Why don't we make a list of all the little minor stuff that could make it play better? I'm getting my paperwork. Y'all hang on. I'll be right back. I got it. I'm coming back. I'm way over here, but I'm coming back. All right. So the figure eight thing doesn't work right. The figure eight. If I put that, I will know exactly what that means. Okay, and then the one-way gate at the top does not work right. Okay. So we'll do it again. See, this one down here is the same thing. You go through it, but you're not supposed to be able to go through this way so that the ball doesn't go back down into the shooting lane. That drop target doesn't work. Those rollover switches aren't working. Something did up there, but... So the kickers are not kicking. The drop targets, since it can't tell that they're down, it can't reset them. The spinner works good. The pop bumpers are working good. Okay, we turned on the lights on the pop bumpers. Watch this. That one wasn't that bad. Whenever it rolls off the in lane, you want it to be smooth. Let's see if I can catch it. I'm not going to be able to get it to do it. Ah, it's playing with it. When it rolls down through here, it should smoothly come off here onto the flipper. I'll give you a better shot. If it bounces right there, you need to either replace these or adjust them or something. Kickers are not working. The kickers aren't working, people. Let's write that down. Kickers not working. The rollover buttons on the right are not working, reliably at least. The ball eject, sometimes it throws it back in the trough instead of kicking it all the way out. How's it going, man? I guess some of those are working. Okay, let's play another game and see if we see anything else. Almost made it up there. Yeah, see, it didn't. You didn't see it probably, but it tried to bounce out and then went back in. Oh, it did it if I didn't go as fast. It bricked the drop target a little bit. Okay, so I think we got a pretty good list of stuff to work on, and then of course, like I said, we need to keep watching to see if it blows the fuse again. So let's see, which one should we do first? Let's look at the kicker's not working. That ought to be fairly easy. Now, I didn't work on this machine before. It's just a customer bought it and they brought it to me to kind of get doing its thing. It was already working though, kind of. So we're just doing you know, little minor adjustments and repairs. So the kickers are not working. I'll bet they do work. It's just they don't work perfectly. You got a light bulb here that's touchy. Let's see if we hit it a little more direct if they work. No, they don't. Okay, let's try this one. Huh. Yeah, they are not working at all. What's that all about? What's up with that? Didn't we do a solenoid test? I thought they worked in the solenoid test. Maybe not. Okay, so we're going to have to go a little deeper. Okay, folks, so luckily he has like a complete set of manuals and stuff. A couple sets, actually. They're also available online. But we're looking in the game at the solenoids, okay? So it's telling me that number 20 and number 21 are the kickers. 20 is the right kicker, 21 is the left kicker. So we're going to go in the solenoid test and see if when it gets to 20 and 21, if the kickers fire. No, I went right past it. Takes a second to get back in. All right, here we go. 20 and 21. Aha! So they do work. It's just they don't work when you hit the switch on the playfield. Interesting. Very, very interesting. Okay, so if you look under the playfield, these are the kickers, and these are the switches to the kickers, and they're wired up. It looks like they're properly wired up to me. I don't see anything obviously wrong with them on both sides. So I don't think it's a mechanical thing. And I don't believe it's just that the switches are dirty either. No matter how hard I push them together and move them around, I can't get either one of them to fire. So I think it's going to be something on the actual board. So we need to look at how these are considered special solenoids. So we need to look at how the special solenoids work to figure it all out. Because what good is a game without kickers? Come on now. You got to have the kickers. Okay, so here is the manual. So like I said, they call these special solenoids, not just the regular solenoids. The reason they're special, you see it's the 3 jet bumpers, left, right, and regular. The right kicker, the left kicker, and then the 3 flippers. The reason they're special solenoids is because they want the computer to be able to control them, but they also want them to be, they want it to be immediately controlled by switches on the playfield or in the cabinet. And they thought that that would make it basically a quicker CPU cycle. So if you hit a switch on the, let's see here, which one would be a good example? Let's say the drop target resets, right? So the drop targets go down, that hits a switch, or makes a switch close. The switch tells the CPU, which is strobing the switches. The switches are all strobed. There's a matrix on these. It's strobing the switches. It finally, after a millisecond or whatever, sees that switch is closed. and then it looks at its code or whatever and says, if this switch is closed, then do this, right? And then it sends out a signal to tell the solenoid to reset the drop targets, right? But that takes a little bit of time. So the ones that they want to work really, really fast, they made what they call special solenoids, where what happens is you hit a switch, the switch tells the coil to fire. It doesn't have, the CPU doesn't have to be involved. Okay, so we need to see, since the computer can turn on the left and right kickers, that means that the transistors are fine. But whatever circuitry is shorting the switch signal to turn those on must be messed up. So let's look at the schematics of the driver board and we can figure that out. Alright, so here are the schematics. Now on the other thing, if you look left kicker, see how it says Q10, and right kicker it says Q8. Q10, Q8, that's what you need to know, and they are special solenoids. Okay, so on the schematics we have this area, schematic of the driver board, sheet 2 of 2. They don't call them special solenoids. They call it switch solenoids. Switch triggered solenoids. Okay? But luckily, since we know it's Q8 and Q10, we can figure it out. Here's Q8 and here's Q10. So what you would assume is that whatever's causing this one to be screwed up is causing this one to be screwed up. So the way it works is, this is the switch triggered solenoid drive. So this is the line that goes out and pulls the solenoid in. Now remember, it's working when the computer tells it to. So that means this is working. This little pre-drive transistor is working. This IC9 must be working. And then this strobe is working. So I mean, why would it not work? Everything that it ought to be working, right? The computer can make it do it. And it can have the trigger, which is the little stand-up switch. Right, so here's a little pull-up resistor. If it sinks low, so if the switch connects to ground on the playfield, right, instead of the computer having to send the signal, the switch itself sends the signal through the same architecture and makes it happen. Makes it trigger. So it's just a way to short circuit the CPU out, and they all have the same setup. Okay, so but we have this interesting situation where IC9 must be working because you need it to work for the computer to do it. And IC7 you would think would be working because it's working when the computer tells it to do it. Right? And then, to make it more complicated, Q10 is ran by IC7, and Q8 is ran by IC6. So they're not even the same chip. So I think the problem has got to be, it may be the pull-up resistor or something on the board, but I think the problem can't really be on the board because there's nothing here to really screw up unless both of these chips have screwed up in such a weird way that the computer can still turn it on with pin 13 or pin 4, but not with pin 5 or pin 12, right? So, I mean, come on now. Come on, people. I don't think that can be it. So it must be that this switch, trigger 4 and switch trigger solenoid 5, that these two lines must not be getting back to this chip. So it might be a broken trace, it might be a screwed up connector on the board, it might be the wire is messed up in the cabinet, these two wires are broke somehow. I don't know. So it's on 2J13, pin 4 and pin 8, right? But right next to pin 4 is pin 3 and 2. And they're working. And pin 5 is working. And pin 9 is working. So, I don't know. usually there's like a common denominator here, and you go, oh, they both use that chip must be messed up. But it's not really like that. So I'm going to get the multimeter and see if I can track down those lines and see if they make it all the way back to the board, or if the connector's messed up or what, and then we'll figure it out. All right, so how are we going to figure this out? Well, one side of the switch should be connected to ground because it needs to ground that input to make that happen, right? And just a quick way you can tell if it needs to ground it or raise it to 5 is because there's a pull-up resistor on it. So it's when it's not connected to anything, it has a resistor tying it to 5, so it's holding it high. Well, it must be that it triggers when it goes low, right? Okay, so I have my multimeter. There is a ground wire here on the back. The back box, all the grounds are tied together. There's a big metal plate on the back box, and everything is screwed to that metal plate. So there's a wire right here. So I've got one of my probes there, and then I have my meter set on ohms resistance. And if I touch one side of the switch, I have 0.6, 0.7 ohms resistance between it and the switch. Now this meter has like 0.2 ohms resistance in it just because of the leads. But basically this one side of the switch is connected to ground, okay? The other side of the switch is connected to the board. So looking through the schematics, it's pin 4 on this connector, okay? So there is 5K ohms resistance between that switch and ground right now. And if I hit the switch together, I have just connected that wire to the ground on the other one, which is what the ball would do, right? And now there's 0.7, 0.8 ohms resistance between ground and that wire. So what does that mean? It means that the switches are working fine, and it does it on both of them. So the switches are grounding that line. So the next thing we need to see is, does that line connect to where it needs to go on the board? So I believe I had it figured out that it goes to IC6 pin 5. IC6 pin 5, okay? Which is this one. It's 2.8 ohms resistance. That's not great. It should be like, ultimately you would want 0.2 ohms resistance. But it does connect to that IC. There has been some work done over here. A couple of the chips have been replaced. But our problem is the solenoids work, the switches work, and the switches connect on the board to the proper IC, and it's two different ICs. So there's no real obvious answer to why it's doing this, right? So what I'm going to do is I'm going to remove this driver board. I'm going to resolder the connectors, and we'll work on it a little bit. We can check some more connections and stuff on the bench, and hopefully we'll end up figuring out what the problem is. Okay, so here is the driver board. Now, this all looks really confusing, but we're focusing on just a couple little things right now, right? So the switch inputs are up here. The switch matrix is here, but the switches we're talking about plug in over here because they're just for the special solenoids. The rest of the switches on the playfield are all handled up here. It seems like most of those are working. When I went in the test on the previous video, when I pressed all the switches, I could get all of them pretty much to work. So I think all of that's working. This is all the lamps, this whole area here. You can see some jumpers here. There are some big old resistors that are usually on here, but they've updated these drivers to where they can get rid of the resistors. It's just an upgrade that they can do. All of the lamps are working, with the exception of maybe that one that kind of works and kind of doesn't. So this area over here is the solenoids, okay? Now there's the CPU board that sits up here and controls all of this, and the way it controls it is with this peripheral interface adapter chip, also known as a PIA chip. Right, this one handles the switches, this one handles the lamps, and this one handles the solenoids. Now you can see that it's been replaced at some point, but that can't really be our problem because when you go and test, it makes all of the solenoids work. Now you may have seen some of the numbers that fired or that were on the display and no solenoid fired. That's just because there's extra solenoids that you don't use on all the games. So on this particular game, not all of the solenoids are used. And then whenever it did the 2 kickers, it was able to make them fire, right? So we know that it used the PIA to do that. It used one of these decoding chips here or whatever to do that. It used the, or not decoding, but logic chips. It used the transistor to do it. So our entire concern is with the switch grounding over here and basically these 2 chips that read it. So one of them's reading one of them that's not working, and one of them's reading the other one that's not working. But whenever I try to check it, I don't really get a problem. So a way you can check these is you can check, since they have gates in them, you can actually check them with a multimeter. Not completely, but to an extent. So if you take like your red probe and put it on ground, which by the way, in this game, conveniently runs all the way around the edge of the board, right? You can use your other probe to connect to the pins of the chip, right? And you'll get some interesting readings. I'm checking it with a diode check, basically like you would check a transistor. And so we're looking for one, you know, that's basically open or whatever. Now, if I go to the one that actually is used by that pin, it reads just like the other ones. And if I go to the one that was used by the other switch, it reads just like the others. So it's hard for me to believe that these chips are bad whenever everything I can tell they're testing fine. So I think what may have been happening was we just had a bad connection on the connector here. Now on the back, all of that has been resoldered by somebody, and if I check it with continuity, you know, with the meter, it's connecting to the pins that it should connect to. So I think the problem is just a dirty connector. It could be that these chips are still bad, but they test fine, so I don't know. And then this is the connector that connects it to the CPU. This is the original one. These, over time, they have a certain lifespan of how many times they can be installed and taken back apart. And these are a known issue. So whenever the CPU is turning on things and turning off things, it uses this connector. So I'm thinking that part of our reason that one coil locked on and blew the fuse, and apparently has been doing that, may be because maybe this connector isn't doing what it should do. So I'm going to replace that while I've got it out. And then I'm also going to find the one transistor that resets the 3-bank drop target. I'm going to replace it just for the heck of it. And it's a tip 102 transistor. So I'm going to put a new one in, and hopefully that'll, just in case that's been an issue, you know, because we saw it lock on the previous video. And so along with that being replaced, I can't really find anything else wrong with it that I think needs attention. I looked at this chip that's been replaced and this one, and the sockets look fine. Everything looks cool. So it's not that too big of a deal, apparently. So we'll hope that the connector was the problem. I'll replace the pins inside the connector in the machine and see if that gets our kickers working. If it doesn't, I'll replace these 2 chips. Maybe I'll do them one by one. That's one of the things with working on these driver boards. You end up putting them in and back out. You could rig up some kind of elaborate test, you know, where you get all this running, and then you ground this one, and then you see with your logic meter, with a logic probe, if this does what it should do, and if it grounds the driver like it should, and then check the output on the pin. But it's easier to just put it in the machine and see if it works. But you end up having to do that 2 or 3 times. So I'll replace this connector and that one transistor, and then we'll see what happens. Okay, so there's our replacement connector, and this was the transistor. Okay, everything else looks cool to me, people. Here is the part number on that connector. Look, I'm getting low. I'm going to have to order some more. And they're obsolete. Going to be hard to track them down. Okay, so I'm going to go put it back in the game, and I'm going to replace the pins on the, the connector that wouldn't work, and see if that gets them going, or if I need to take it back out and start swapping chips. But best I can tell with a multimeter, the chips are fine. Okay, folks, I've got good news and less good news. Here's the good news. Here's the less good news. One of them works, the other one don't work yet. Well, come on now. Come on, people. How come the one that I took the plastic off of and messed around with? How come that's the only one? How come that's the only one that works, people? Come on now. We got to do better than that. Okay, so the one that works was pin 4, pin 8 is all connected. Everything seems just swell. I don't see what the big problem is. Is that a broken resistor? Tell me that ain't a broken resistor. No, it's not. Okay, we're good. Yeah, so I don't know. Might end up having to swap that one IC. Well, we got one kicker working. It'll kick one way, it just won't kick the other way. Okay, folks, so here's the bottom of the playfield. This one's not quite as clean as the other one, but it doesn't really matter if it's on the bottom of the playfield. So we got our right kicker working, our left one's still not working, but looky what I found. What is wrong here? Can you tell? I'm just going to show you a close-up. You tell me if you see anything wrong. You see anything yet? Look, it's kind of like we're up in the air and we're staring down on Manhattan. This is a big skyscraper. See all the little people down there? I've been working too late again. All right, do you see anything wrong? What in the world is this? Oh, this is a wire that's not connected to anything and was touching over there, but not really. It was kind of just hanging there, and it kind of looked like it had been soldered there, but it's not really. It's not really touching anything. So this is the ground wire that goes to this side of the switch, and then whenever you connect it, it sends the ground through this wire to ground it at the board. Now, if I would have, you saw how earlier I took that plastic off and tested that side, right? If I would have done the same thing on this side, I would have caught it. But hey, I still caught it, just afterwards. Okay, so basically this wire needs to be soldered here, not hanging over here, not touching anything. So that should fix that. Let's test it. Okay, so let's try it. Maybe for the first time in perhaps 40 years, the kickers will work. Still looking to see if the fuse blows too. Come on, kickers. We're gonna need some kicking. Oh, the kickers are working. Okay, so our first step to a better playing game is you got to get the kickers working, people. Oh. There we go. They slid it right past me. Well, I'll tell you what, the pop bumpers work. Ooh, let's cheat. They seem to be working great, actually. They're kicking, which is what you want, right? So the rollover buttons up there, I can see are getting stuck down is what's happening with them. Yeah, see the top one's stuck down right now. So let me show you. See, it's stuck down. That one's up. That one's stuck down. So they're sticking. Now why do they stick? It's because wax gets in all of these little cracks. Now you can pop that little thing out and clean all those little cracks, and that will get it where they don't stick. So there are 5 on this game. That one's working pretty good. And that one's working pretty good. Notice that one's orange and those are red. From what I understand, I may be wrong, but from what I understand, it's common on Flash for some of them to be the wrong color. They kind of just ran with whatever they had. That's what I've heard. So maybe that one's been changed, but if you look, see how it's like it chipped up a little bit around it? That one is too, you know. I think that might be original, and one of them was just orange from the factory. Okay, so I'm going to clean those up a little bit. That'll be our next step. I'm going to, from the bottom, you can pop the little white thing out, and then clean all the little crevices, and then pop it back in. All right, let's test them. That one seems good. Did it stick? I couldn't tell. I was looking through the camera. I think that one seems good. And that one seems good. Okay, and those two as well. Okay, so we got that. So let's look at our list again. Reasons the game isn't playing great. Kicker's not working. We fixed that. Rollover buttons. I think we fixed that. The ball eject, the ball bounces out and then sometimes bounces back in. That's messed up. The figure 8 thing doesn't line up right, the shot. And this one-way gate up here is a two-way gate because there's a little piece broke. I think I may be able to bend that piece and make it work, but we'll see. Let's mess with that first. Maybe I can find one of those. So basically we want it where the ball can go through here, but we don't want the ball to be able to go through this way. So the way they usually do that is there is a little piece. This one's a little different. There's a little piece. Oh, I got another flash right here. Maybe I could look on this one. Maybe there'll be some clue. Maybe there'll be something similar on this game. So I don't know if you can see it. I got to brighten it up. Very, very bright. Okay, see the wire going through, and then it goes down, it forms the thing. And then when it gets over to this side, see how it's bent? It's bent so that the wire can open up this way and move that this way. But if the ball hits it, that little wire that's bent will keep it from allowing it to go back through. Right? So it can only go one way. So basically what's going on with that one over there is it has the wrong wire form on it. So I'm going to see if I can find another one, or maybe we can bend that one, get cutesy with it. I'll see if I've got anything similar to that and what we can do with it. Okay, folks, so I am simply just bending a new one, right? It looked like this one was a little crooked in there, so I made it a little slightly different. We'll see if it fits right. And then this part I just left long, so I can cut it off whatever length it's supposed to be and shape it a little bit. You can get wire like this that you can just bend yourself. We do so many of them, we always have some around. This, one thing you can make it out of is I bought this at Lowe's one time. Suspended ceiling wire kit. It's slightly too, it's not quite as rigid as the original wire, but it seems to work just fine, and that kind of makes it a little easier to bend. So there's probably something you could get that would be slightly better, but basically you just bend your own whenever you got one missing. And if you just take a pair of needle nose pliers, you can get nice square edges like the original ones had. So let me go mock it up slightly more, and we'll slide it in the game and see if that will work as our one-way ball gate. Okay, so we got it reinstalled. Let's see if the ball can go through it, but not go back through it. What do you think? Well, I need the ball to try that. Went through it, so it can go through it. Goes through it just fine. Ooh, missed it. She's definitely starting to play better. Still got to mess with those drop targets. Well, I thought we had a shot that we needed. Don't we need a shot right up through the spinner? Isn't that the test? That would be the test, wouldn't it? I never hit it. Bang! We hit it that time. All right. I got to get that figure 8 thing a little better. And our little rollover buttons appear to be working good. She's coming back to life, little by little. All right. It's starting to play more fun. Little tiny things. You work through them, do a little bit here, a little bit there. It gets more and more fun. Pretty soon it's going to be amazingly fun. We're not even going to believe how fun. People, why do you encourage me? It's like you egg me on. You leave comments telling me how good the video was, and then I keep doing that kind of stuff. I had to go sit down and relax. It was too fun. All right, so we still got plenty we got to do to it, but it's coming along. It's a lot better than it was, and the power connector has not slid off on its own yet, but I have a feeling it might in the next video. So leave your comments below. Make sure to give us a thumbs up for taking the trouble to film it for you. Let us know what you think so far. Do you think they're starting to match a little bit better? We're kind of starting to get 2 decent pinball machines here. Look, the flasher bulbs are working. I replaced them, though, whenever I went through and did the bulbs. I think it's all coming along pretty good. We'd like to thank everybody that's been using our Amazon links. If you don't know about that, I think I mentioned it earlier, but if there's a link down below, if you're going to buy anything on Amazon, use our link, and it gives us money. So we appreciate people that have been doing that. Even if you don't buy what we're advertising for sale on Amazon, if you're going to buy anything on Amazon, if you use our link, it gives us a little tip. Thank you for that. And finally, don't forget to check out my brother Donnie. My brother Donnie is literally my brother. He has his own channel here on YouTube. And if you like watching us work on these old pinball machines, you may enjoy us watching he and I work on old buildings, old trucks, old cars. We've been doing all kinds of fun stuff over there lately. I'm usually on his channel with him. So go make sure to check that out, the My Brother Donnie channel. So we appreciate it, folks. I hope you enjoyed it so far. We will see you on the next video where we'll keep working on it. We've still got to do the drop targets, look at the flippers. And what was the other? Oh, that little S thing. That's the most important thing. So we still got to fix that. And then we also have to touch up this paint on the playfield. I thought we were going to get to it in this video, but the kickers really kicked us. The kickers weren't kicking right, people. You got to have... People, you can't have the game without the... I mean, I know it took a while, okay? Come on, people. It took a while to fix, but you got to have the kickers, or So how would it be if I told a guy, hey, the game works, but the kick, come on, people. Come on now. I can't tell them that the game's fine and that back in the day they didn't even have flippers. It was just the kickers. How would it be if I said, Rodney, your game works, but the kick, come on now. Come on, people. I can't do it like that. You know how upset he's going to be if his kickers don't